quick introduction. I'm a cloud engineer and also a DevOps engineer. I've been in this industry for the past 10 to 12 years. Started from traditional network and system to virtualization, and eventually moved to the cloud, and I have worked with Amazon, eventually moved to another private entity. Okay, in order not to let everybody wait, let's start. On this call, I believe there are people that are pretty new to the cloud or people that are already experienced in the cloud. For that reason, let's start with the agenda. Okay, the agenda is basically going to look at a quick introduction to the cloud as a whole and also AWS. Then we'll move to AWS account and access control, where we're going to create an AWS account as well as set up the initial credential and best practice for access management. After that, we're going to move to AWS Networking, where we're going to do a contrast between AWS and traditional network, because like I said, the objectives of this training is to kind of give a line of sight to those who are coming from on-prem primarily, so that they can see things, they can match the cloud to what they're already doing on-prem and also see the advantage that the cloud is going to offer them. And eventually, we're going to look at AWS Compute, which is basically how do you call it, EC2 instances and storage. This is actually the summary of what we are looking at today. And within those processes also, we're going to discuss some few migration strategy when it comes to having to move your on-prem infrastructure to AWS from the network perspective as well as compute workload perspective. Are we okay? Let me know if I'm too fast or do you want me to go slower? Cool. Let me just move this screen down somewhere. Yes. All right. Let's start with the session one, which is introduction to the cloud. Basically, what is the cloud? I believe most of you already know, but I'll just reiterate that. It's basically an on-demand IT service over the internet, and with a modality of having to pay as you consume those resources. It's a pay-as-you-go services for on-demand IT resources. That's how we can summarize that. And what are the benefits of the cloud? In summary, we have the agility, the elasticity, the cost saving, and the global reach. I don't think I need to expand on that. Let's move to the next one. Okay, what are the various type of cloud service model that we have? For this, we're going to look at the first one, which is we call it IaaS, which is infrastructure as service. Basically, that is where most the system administrator and network as well as developers are going to find themselves, where you have a complete stack where your application, your data, or from the OS upward is actually your responsibility. And the cloud provider takes care of the networking, the storage, the server, and the virtualization. Similar to what you
excuse me, Christopher, you're not sharing your screen.
Oh, my bad. Interesting. I've been talking for long for nothing. Okay, can you see my screen now?
Yes.
Let me know if it's just a screen. Beyond that, do you see the other page? Okay, this one is just one. Just a second. I'm going to share it again. This time, I'm going to share an entire window. Okay, can you see my screen now? Okay, cool. Yes, as I was saying, the cloud is basically IT resources as a service on a pay-as-you-go model, where you pay for the resource that you consume and you have access to it over the internet. That's briefly that. And the advantage, like I said, is basically agility, elasticity, cost saving, and global reach. Now, what are the various type of cloud that we have? We have infrastructure as a service, which is basically compute, storage, and networking workloads that you rent in the cloud. And from that particular model, you take care of everything that is from the operating system upward. And that is similar to what you have when you're doing virtualization on-prem. And I believe we have people over here that have experience in virtualization, right? If you have experience in virtualization, just give us some thumb up so that I'll be able to have a fair idea that my audience can listen to me. Awesome. Okay. Similar to that, you basically have you taking care of the operating system and upward configuration, and AWS take care of the hardware component of the cloud, which is networking, your sound storage infrastructure, your server infrastructure, the bare metal server infrastructure, and the hypervisor. Then we have the PaaS, which is platform as a service. That is also similar to the infrastructure as a service, but with the exception of the operating system and the mid layer. That means you're going to fund yourself to use services that are running on top of it. And I'll give a typical example. That could be something like a deployment platform or a managed service from a cloud provider. And then eventually we have the SaaS, which we all know about. And a typical example is what we are using right now, which is a Google service, where we don't really manage anything. We just consume the software that is provided to us. Office 365 is also another example. And all range of applications that we run in the cloud are basically considered as SaaS. Okay, what are the various deployment type of the cloud? And from what you can see over here, we have basically 4 types. The private cloud basically is like you running your virtualization infrastructure on-prem. And I'd give a typical example like those who are using OpenStack in-house, for instance. That's a typical instance of private cloud, or those who are using, I think, VMware Cloud, if they say something like that. That's basically something you're running on-prem, belonging to your organization, but still running the whole virtualization stack where you're rendering compute and storage services to your various departments internally. Okay. Then we have the public cloud. The public cloud is what we all know, which is basically platform like AWS, Azure, where we're renting those compute, storage, and all those things from a big player in the industry. Then we have a hybrid cloud. And basically with the hybrid cloud is basically we're talking about an integration between your on-prem and the public clouds. And that is basically something that is becoming more and more common in the industry these days because of the flexibility that it offers you, whereby your internal resources are more hosted in-house, and then your external consumer resources are basically in the cloud. Then we have the option of multi-cloud, where we kind of have to work with multiple cloud providers. Like you have an infrastructure that is running partially on AWS, on Azure, and on Google Cloud, combining all those 3 in order to offer yourself the high availability that you are looking at. And a typical example is what happened right now, where because Google, I think Google Meets and some of their services went down, we couldn't continue this conversation. Cool. Moving to the next one is the difference between an on-prem infrastructure and a cloud compute. I think there's a lot over here, but one of the key things we have to pinpoint when it comes to the difference between the two is that one is CapEx oriented, whereby you basically have to spend all the money for your infrastructure upfront, and then the other one is OpEx oriented, where you only pay for what you consume for a specific period of time. That means that, for instance, if you have to deploy an application and that requires to acquire a server on-prem, you have to go through the entire procurement process, acquire the server, do your initial installation, and even making sure that you get the server right, and before deploying your application. And that process can quite take long. When it comes to the cloud, you basically have to make sure that you can start however you want to start. You can start small and fine-tune or right sizes as time goes on. And another thing is that yes, everything in the cloud basically will have something we call shared responsibility, whereby the cloud provider will take care of the big part of the underlying infrastructure security, and you as an individual or company using the cloud, you're going to take care of the upper layer. Whereby on-prem, you basically have to take care of everything from from networking to storage to server to operating system and to application. That means you have the full stack that you have to take care of. What else can I pinpoint that is really important between these two entities? Let's say, yeah, another major difference is that one is basically manual. When you're doing your on-prem deployment, most of the time is manual because you have to rack and stack your infrastructures, deploy your operating system, install your application, and it's quite manual. Whereby in the cloud is mostly an API driven activity. Yes, a second. All right, cool. It looks like we're having some bandwidth issue, therefore I'm turning my camera off. Can you guys still hear me? Cool.
Yes.
All right, awesome. That means at the end of the day, moving from on-prem to the cloud requires some major change. Basically, the approach of a resource acquisition. With on-prem, you have to pay everything upfront, as I said previously, and then in the cloud, you start small and then eventually grow based on the need of your organization. Okay, now let's tackle AWS. AWS Infrastructure. Basically, AWS Infrastructure is built around a certain concept that we call region, availability zone, and edge network. By AWS region, we mean a physical location somewhere in the world. And for availability zone, we are talking about multiple data centers that are connected with very high speed connection. And then we have the edge network, which is basically more like a cache services that are deployed closer to where the customers are. I think we're going to go into detail later on when we are looking at each of them. But as it stands now, AWS has 117 availability zones. That means we are literally saying 117 data centers, and we mean large data centers that are spread across 37 regions, meaning physical location somewhere in somebody's country. And then a total of more than 700 edge location, which some people can also refer to as a CDN, content delivery network, for caching. What is one of the key things that you have to understand when you go to the cloud, especially for those coming from on-prem? As I previously stated, responsibility in the cloud is divided into two. AWS is responsible for the security of the cloud. And you as an individual, you are responsible of the security in the cloud. What do I mean by that? What I mean is that AWS will take care of your hardware infrastructure, your storage infrastructure, your network infrastructure that is running under your virtual data center. But from anything from the network configuration at the software layer level to your application and your data is fully your responsibility. This is very critical because when they are issuing the cloud and you raise a ticket with AWS, the first thing that a support engineer is going to do is trying to figure out where the line is, if it's your responsibility or his responsibility. And I've been in situations in multiple occasions where, I mean, a customer raised an issue, and obviously there's nothing wrong with AWS from the underlying infrastructure side. And the only thing I can tell the customer is that basically the issue that you're having is at the customer level, which is at your level. And whatever as a support engineer we can do at that time is to provide you assistance. I mean, there's no obligation from AWS to really provide you support for things that are beyond the underlying infrastructure. And that's something critical to understand, because as you understand that part, you know to what extent you have to secure your cloud from your side. Are you guys still following me? Awesome.
Yes.
And I hope I'm not too fast. Good. Okay. Now that we have touched on those previous topics, which has to do with the cloud as whole. Now let's jump onto AWS itself. And for this second session, we're going to talk about AWS accounts and access control. Basically, what is AWS accounts? It's basically the foundational entity used to access resources on AWS. Basically, for you to be able to consume or provision anything on AWS, and that's applied to other cloud provider, you need an account, and that's what we call AWS account. An AWS account has a couple of components that you have to be aware of. Is that every component, every AWS account that is created has a unique ID, and usually when you have issue and you have to raise a ticket with support, obviously the first thing there they will cross-check is the request coming from an account that is related to the email associated with the request. And if it so happen that AWS identified that, oh, the ticket you are raising is coming from a different account, automatically they will tell you that you should go back and create a ticket from the right account. That being said, an account is made up of an account ID. And while creating an account, you're supposed to use an email address. And that email address is usually referred to as a root email address. And root email address, root user, or root email address, if I can call it that way, is basically the most powerful credential on AWS, meaning that if that particular root user account is compromised, you can find yourself in a situation whereby an unauthorized person get access to your AWS account and literally erase everything. And that is one thing with the cloud compared to a physical environment, whereby a physical environment, for somebody to destroy it, requires somebody has to taking servers out of the data center and all those things. But in the cloud is basically API calls, and you can find yourself with 300 servers that are just wiped out of your environment like that. Okay, another component of AWS account is identity and access management. It's basically a service in AWS that allow you to create users group and also role to manage permission within that environment. The next thing is AWS organization is also a service that allow you to manage multiple AWS account together. And as part of the AWS account, you also have something we call billing. And in addition to that, you have all the AWS services. Before we proceed with the account creation, let me say, we're going to look at IAM, which is a very key component. IAM is also referred to as identity management. It's basically the major service that allowed us to control user rights and accesses within our environment. And for those who are coming from on-prem, I'll use an example of any services that in which you have users and group that you grant permission. It could be a database, or a typical example could also be an Active Directory service where you create users group and then assign permission to those users on what they can do on your resources. That's exactly the same thing with an IAM. It's basically that, and there are two entity in how do you call it, in IAM. You have the entity which are basically the users, and then you have the policy. Those two comes together in order to allow you to be able to grant access to how do you call it, to users. Are we there? Is it slow? Is it too fast? Please let me know. Cool. Now we're gonna move to the demo. But before that, is basically this demo consists of having to create an AWS account. Now, for those who are new to this, like I said, you need an account in order to have access to resources. And to that, we are going to the browser. Okay. For this, I'm using kind of an in-house or self-hosted cloud services. That means we are using this browser, and here we simply just have to, you can even just go to Google. Somebody's raising a hand.
We can't see your screen. Can you share your screen again? Because or share that window.
Okay, hold on. Let's see if you guys can see my screen. We are sharing an entire window. Okay, can you guys see my screen now? Okay, awesome. We're moving from here and we're going to this. Let me just close the page and let me see. We can just go, anybody can just go to the browser and look for AWS. Let me see. AWS. Go to google.com, look for AWS, and then you just click on this. Then you come to, I think, complete sign up. Let's see what we're going to get. Yes, you're given this console where you have the option of creating a new AWS account, if I can call it that way. Click on sign up. You are required to provide an email. And here we're going to use this simple email. Okay. And you can use any email, but just remember that this email will become your primary login account to your AWS. And then I'm going to give it a name. Here, I'm just calling it Crowd Training. And remember, you can create an AWS account anytime you feel like, just that you have to remember, I think there's a component of having to provide your credit card detail for billing. But usually when you start, it's going to come with some free tier where you can start spinning some few resources just to try your hands on. And then you click on verify email. This is going to send me an OTP. Let me just quickly check that, see if I've received it or not. Okay, my OTP has arrived. And it's basically 037107, I believe. Okay. Now it's asking me to set the root password. And obviously, for this situation, we're going to need a very strong password. And usually I have a preference to use a passphrase rather than trying to use a very complicated password. Guys, allow me to generate one. Let me see if I can just write it somewhere down. Let me see if I can find one of my tools. Okay. I'm using a very simple one, but it's quite long. Let me see. I say, I want tomorrow to be great. That's my password. Let's see if I can get it right again. I hope it matches. So there's a mismatch. Okay, let's see. Can I do a copy and paste? Okay, now going through, but let's not fuss about it. Let me use a simpler one just for the purpose of the training. Okay, this is publicly known. Okay. I'm going to add more complexity to it and see. Okay, this time it's gone through. Now, as I was saying, you're required to have your credit card detail ready. And for this, I'll just leave it here, but I guess you all know what I'm referring to. Let me see. Maybe I'll take this one offline just to fill it quickly, and then we can come back to this. Okay, just give me 2 minutes. We all want to keep our credit card detail secret. Any questions so far? That would be a good time to have a question while we're trying to get this sorted. It would be good to have a question. I've been speaking for how many minutes now? Anybody with a question? Yeah, go ahead.
I have a question.
Okay, please go ahead.
Yeah. In your submission, you said you could use the free tier. So why do you need to provide your credit card information or debit card information if you could use the free tier?
Yes. Okay. Good question. Yeah. Basically, the free tier from AWS perspective still means that you have to provide your credential detail. That means beyond the free tier, you start being billed. AWS just want to avoid a situation whereby people don't take their account seriously and also probably consume beyond what they're supposed to consume. That means it's free tier, but that still require you to put in your credit card details. Did I answer the question? Are we there? Can you hear me? Hello?
Hi.
Yes, yeah.
Okay. All right. Cool. Yes, I'm just punching in the credit card details, and then we can continue from there. Anybody has a question? Additional question? No question. Great. 35. Okay, I think after passing that stage, it's asking me to confirm my ID. I've put in some numbers. I will still keep this one also secret. But basically, a page where you have to provide your let's see, your telephone number. And at this point, I'm asked to fill in these characters. I think ZZZN7 and 5. I hope it's correct. Okay, now I'm waiting for the OTP to be sent to me through a text message. Okay, something has arrived. Okay, now we pass on to the next stage, which is the support plan. And for this, we're going to go with the basic, which is the free support plan. And as you can see, there are three options over here: developer, and then the business. For developers, you have almost $29 per month, and then you have the business that starts from $100. Okay, congratulations. My account has been created successfully. Now, let me try to log in to my console. And that's it. We just created an AWS account. And as usual, the console of AWS change very often. Now, after you create your AWS accounts, the first thing you have to do is to try to secure your accounts. And I think the first thing we have to do is trying to see if we can set up some of our account security, like setting up an MFA on our accounts. Let me see first. Okay, I think here's the billing aspect. Let's go to the IAM parts. Let's see if we can set up this IAM user root account, root access management, I believe. Oh, interesting. There are a few things that have changed again from the console perspective. Let's say policy, token. Let's see if they have a secure credential. Okay, yes. When you log in for the first time, you have to come and secure your credential over here. And then I think this one is for our root account, and there's a section called MFA. All we have to do is to assign an MFA device to it so that we can have a multi-factor authentication for this account. Here, I'm just going to put first phone, maybe just give it a name. And this time we're going to use, how do you call it, a Google Authenticator or any other authenticator app that you have on your phone. Oh, sign that's the name. Shouldn't have spaces. Cool. Let's say underscore. And click next. Awesome. I guess for this, what we're going to do is, in order to avoid conflict, or this is still a free account, I'm just going to show the OTP. For now, I'm going to pull it out so that we keep it confidential. Google Authenticator. Let's see. Simply going to scan that one. As soon as I scan that, I'm giving the first key, which is 859. Now I'm waiting for a second one. Okay. That is done. That means we are back here. My MFA has been set. And like I said, that is the first thing to do as soon as you create an account, is to come to your account, come to secure credential, and over here, you add your OTP. As soon as this is done, that means we can now move to the next step. And what the rule of thumb is that your root account is not an account that you're supposed to be using on daily basis. It's one of those accounts that you create because it's your master key, you store it somewhere, and literally forget about it. The only time you need it is probably when you are dealing with things like this, where you have to validate your account for some reason. The first step we are going to do is to create a user. This, like I said, this is not different from what you usually do in your environment. We're going to create our first user. And for this user, let's try to find a name for him. Let's say AWS trainer. That'll be the name. And one of the things you want to do is to provide this user access to the console. Okay. And for access to the console, I need to provide a password to this individual or let AWS generate it. But for this case, we're going to set our own password. Custom password. Because we are actually in the test environment, I want to check this option. But in real life environment, when you're creating a user for somebody, you just check this one so that the next time the person logs in, they can actually reset their own password. Are we okay? I'm gonna skip the group membership for now. Just click on next. And then we create this user. And the password is also here for the console. Let's see, is anything I'm missing here? Okay, when it's done, there's a URL. Any question? I think I'm hearing some.
Yes. I have a question.
Okay, go ahead.
I'm looking, when we're creating the account, we went to like AWS.com, but looking at the console sign-in URL, I see some numbers appended to it.
Yeah.
So, yeah.
Yeah, go ahead. Yeah, finish your question.
Yeah, so like, can you throw more light on that? Can't we just go to like aws.amazon.com and sign in? Why do we need to use this specific URL?
Oh, yes. Basically, you can do the same by going to AWS, AmazonAWS.com. But the only thing is that this is basically a custom URL, especially when you are sharing to somebody who doesn't know that the person has to go to Amazon.aws.com. That's basically the purpose. Because this number you see here, remember when I was doing an introduction on the account itself, I mentioned an account ID, right?
Yes.
Yeah, this is the account ID. That means that's the unique identifier for this particular account. That's why they put it in the URL to make it easy for anybody else. Like for instance, if I copy this one, let me see if I'm trying to create a new tab. Can I go into cognito modes with this one? Let's see. You see, it's directing me directly to this place. Because one thing you have to see is that after you create the user, remember the first time we create, oh no, I want to sign in for this one, reload. Yeah, let me just reload this page first and go back to as a root account. Okay, this page is really good. It gives a lot of information. You see that when you go to AWS.com and Amazon, AWS at Amazon.aws.com, you have this particular page, right? You have the IAM user login, and then you have the root credential. When we created the account for the first time, we were using the root credential. But subsequent users need to use the IAM user. And for you to use the IAM user, you are required to provide the account ID or the account alias plus your credential. Is that clear now?
Yes. That's
okay.
clear.
Yeah, because we are still in the process of creating the user, I'm going back to log in as the root user. Okay, that will mean I need to use the email that I used initially, which is dot comma Etou Thinker plus training at gmail.com. I hope I got it right. Yes. Okay. And the password, I hope this one is also right. Now he's asking me for the MFA key. I mean, so I have to now take my Google Authenticator or whatever authenticator I have on my phone that I've registered with the phone with, and then I punch in those details. And if every information I provided is correct, here you are. We are back to this page. And it looks like we've not completed the user creation yet, because if we go to users now, oh, it's here. That means the user has been created completely. But one thing to know, because we are saying that we cannot use the root user for our day-to-day activity, I'm required, for instance, after creating this user, to make this user the almighty admin for the purpose of this training. But for every use case, I will say that always have one user account that has literally the same privilege as the roots. That means it's going to be your master credential, just that it's not going to be your root user account. Is that clear? Now, for this one, we have this, and I'm going to give this user a couple of permission. And here, I think we're just going to go and attach one of the permission from AWS. I think we'll touch on the permission probably later when we are doing an overview of the account itself. Now we click on this, which is administrator access. These are basically AWS managed permission. If you go here, there's a whole list of it. I can't tell what is the total number, but literally AWS work under the principle of least privilege, meaning that when you create a user, by default, the user got no credential. And in some best practice situation also, instead of assigning the permission to the user, you will literally assign the permission to a group and then put the user in a group. But we are jumping that gun for now. Oh, the number is here, 1,357 policy, which has like all type of permission that are managed by AWS. And for this particular user, we are attaching this admin user that kind of grants a super user permission to this particular individual. Okay. I'm gonna click next. Any question? Yeah.
Yes. So I noticed you use the word policy and permissions. Sometimes it's interchangeable. I did the same thing, or there's differences between them.
Yeah. Okay. Policies are basically the written format of a permission. For instance, let's take this particular policy. Now, sorry for going a bit technical, because we have a technical person among us. Let me see if I can give you the JSON format. Okay, yeah. This is a policy document that determines the permission that a person has. And you can see over here, it's called policy because it's a document, but it defines the permission. And the permission says what? The person has allowed to perform all action on all resources. That means you see, most people use policy and permission interchangeably, but policy is basically a definition of permission in a particular format. That's how I can summarize it. Is that okay?
Yes, that
Okay.
sounds good. Thanks.
Awesome. I mean, we're going back to this gentleman that we kind of assign permission to, because he's going to become our master user. Here, there's no policy. I'm going to go and I'm going to just attach one, but you can create one yourself if you want, but that is for another day. We're going to select this guy, go down, and then add permission. And I believe this should add the admin permission to this individual. Okay. In other situation, should I go ahead right away? No, I'll leave it that way. In this account, I should also assign an MFA to it, but I want us to assign the MFA from the perspective of the account user. That means we're going to log out from the root account and then log in as this particular user, which is, I think, our AWS trainer. and then trying to set his own MFA from that, because that's what every individual or any other person that you create an account for will have to do, because you don't want to be present when somebody is setting up those credentials. Okay, that means for now I'm just gonna log out because I think I'm done with what I'm supposed to do here. And I'm gonna go back and going back to the console. And this time, oh, yeah, let me see if I have the email indicating where the user, because I forgot to take note of the account ID. Therefore, it's gonna get a bit tricky. Otherwise, I'll be forced to having to log in again. And I think I will have to do that. Yeah, that's just something that for any new user, you're going to run into this particular situation like me right now. I created a user and I haven't kept track of the account ID that is associated with it. Now I want to log in as an IAM user and I can't remember the credential, the how do you call it, the account ID. Just remember that something like that could happen to you also. Let me get my... That also means that if you have a password manager, it will be good to keep all those information in your password manager for the purpose of having to remember in the future, because in a real life scenario, you may be dealing with maybe more than 10 or 20 or 30 AWS accounts as a cloud admin or DevOps engineer. And I'll touch on the reason of that later, but for now, let me just get what I'm here for. Let's see, what else am I missing? Okay, keep a note of that. Now I can think the trainer also, we said the username is AWS trainer. With these two, I think we can now log out happily and log in as that individual. Here we go. Oh, okay, fine. My keyboard is misbehaving. Never mind. We're just gonna punch it in. 222 48 21 27 143. Okay. And then let's say, remember this account. Just want to keep that one on record. And then we say AWS trainer. And the password, I hope I can recall that. And I'm gonna click next, hoping that I got all that information correct. Yes. As you can see, this has sent me straight into that particular AWS account. And you can see this is the account ID and the user over here. And like I said, we do the same thing here. We go to security credential and trying to see if we can set up our own MFA for this particular user. And I'm gonna go through this one. I think this one I don't mind keeping it so that you guys can see how the process goes. You click on add MFA, and this one we're gonna say trainer phone. Then we go to, we're gonna use a software. Remember, there's the other option. If you have a hardware token device or a passkey, you can use any of those options. But the easiest one that we all use is a software authenticator. Okay, yeah, I'm gonna show this. Anybody there to to just do the same. Never mind. Okay, I'm gonna scan this one first, and when you scan this, the first thing it's gonna do is gonna give you a first OTP, which is gonna be, we're just gonna punch in that one first, and then we wait for the second cycle of the new one. And I think this is very common to other cloud providers or any OTP compatible platform that you use. Okay, I think we have the new one, which is okay, here that's it. If everything is okay, yes, that is set. That means my OTP is also set over here. That means this account is now safe. Ooh. Okay, now we are in this new account. And what did we do so far? I believe we touched on having to create an AWS account and then set up, how do you call it, create a user and assign an MFA or configure the MFA to secure that particular user. Now we're going to go through an overview of an AWS account. We've gone through the initial stage, but usually when you go to an AWS account, basically there are a couple of sessions that you need to be accustomed to. Is basically where the services are located. And as I was saying, AWS has hundreds of services. Basically, AWS has a service for anything under the sun. And for the purpose of this training, we are mostly concerned about things like compute, which will allow you to create EC2 instances. And then I think networking session where we can create VPN, how do you call it, a virtual private cloud for our own data center and so forth. But in summary, this is where you see those details for the various services. And for now, if I click by default, when I click on something like a VPC, which is basically your data center in the cloud, this is what the menu looks like. You have all these components from your VPC to the subnet to the routing table. And I believe network people will see a lot of, how do you call it, similarity to things that they do on-prem, because that's basically what you do. The concept of your prem that you are bringing here in the cloud. The only major difference is that you have more flexibility, and also maybe it's also API driven, I would say. Okay, then we have your VPC is your network. Then you have the subnet, you have your routing table, you have your internet gateway, all these things. Basically, those are your resources for VPC. And the same thing will go to EC2 that we'll look at later on. And that also allowed us to take a look at the various servers that we have in our environment. But there's one thing I also want to touch on, if probably this is touch on the second environment. Okay, I think we can now move to the second session. Okay, I think I'm moving ahead of myself. Any questions so far? We've created the accounts. Now let's go and look at the network component of AWS, a small presentation. And then now we'll come over here to create our first data center in the cloud. Are we on the same line? Any question? Should I proceed? Okay, all right. That means we should proceed. You can still all see my screen, right? Now I'll move to the second session of this course, which is AWS Networking. The first page is to look at the difference between AWS Networking and the traditional network. And I believe the people from my friends and colleagues that are from on-prem, I think you can see the diagram on the left side. That looks similar to things that you have, which is basically, yeah. Go ahead.
You can't see the presentation yet.
Again?
Yeah, we are seeing the AWS console.
Oh, interesting. La. Okay.
I think it has to do with his network because I can see it on my end.
You can see it on your side.
Yeah, I can see it now.
Okay, you can see it now. Okay, cool. I mean, it's not me again who screwed up. All right, cool. Yeah, I'm saying that on the left side, we have a traditional network. And everybody coming from on-prem, especially if you have worked in a data center before, you can see pretty well that you have multiple layers. At the bottom of it, you have your disk layer. Basically, we're talking about those who have SAN fabric, like you're running SAN storage in your environment. You have your SAN fabric infrastructure sitting down here, made up of your SAN array, which is your big servers with disk. And then you have your fiber switches, which are basically fiber switches that are carrying the storage network to your servers that we see over here. Then above your server layer, you have the access layer where you plug in all your servers. Then from there, you go into aggregation layer where you have another level of redundancy. And if you are dealing with a large corporation, you have another core layer, which is another stack of network equipment before you have your internet and probably your service providers. This is what it looks like at a high level for those who are coming from on-prem. In reality, if we go to AWS under the hood, it's something similar to this. That means the layer that we spoke about previously, which has to do with the underlying infrastructure, literally has a similar architecture, more complex than this, but the principle is the same. Because when you move to the cloud, basically what you're doing is that AWS or the cloud provider is literally taking away the underlying infrastructure from you and abstract everything to a software implementation for you. Then here we have the AWS infrastructure, which I would say, I won't talk into detail yet, but we can just look at the matches over here. With traditional networking, you have physical hardware on AWS, or in the cloud, you have software-defined network. That means instead of having to provision a switch, setting up a VLAN, how do you call it? Configure your fiber switch, provision your SAN storage, provision your server, link all those things together. You got none of those things to be done to do in the cloud. It's purely software-based. That's it. Now, in a traditional network, you have to plan capacity ahead of time. That means most of the time, before you say you are deploying an application, you have to know, okay, what is the application going to be used for? Okay, what should be the specification of the server that you have to deploy the application on? And you have to plan all those things ahead of time and make sure that you get it right. Because if you get it wrong and probably your server is underperforming, you're going to have more trouble having to upgrade that server. That means fixed capacity. But in the cloud, you have the elasticity of not having to worry about that constraint. You may choose a particular server today. It's not working as it has a performance constraint. You can decide to scale it up, or you provision a server that is too big, then you scale it down. That is the aspect of it. Okay. You don't have to deal with the procurement process. Like right now, where we just created an AWS account. In a traditional sense, if you have to do that, maybe let's say that you want to co-locate your data center with a service provider where you have to put in your server and everything. You have to go through a long procurement process, and as well as the deployment process. And that's usually not funny. But in a cloud, you don't have that. Now, the other thing is that in a physical environment, everything is manual, rack and stack, like I said before. In the cloud, everything is through API. Even though today we are using a console, behind the console is just API call that are going. But beyond that, also, you can actually automate those processes. Okay? That's what it looks like at a high level. Let's move next. The core component of AWS VPC. Do you have anybody on the call that can tell me what a VPC is and if they have played with that before? It doesn't necessarily have to be on AWS, but on any cloud provider. Can somebody give me a rundown of what it looks like from their perspective? Anybody? No finger up? Okay. Sure. Okay. All right, cool. Basically, your VPC is the foundation of a network on AWS. Basically, it's basically your curve or your own virtual data center on AWS. Meaning that everything that you have in that is under your control. Okay? And a VPC usually is structured in a particular way. Every VPC or every virtual data center, if I can call it that way, will reside in a region. And you guys remember previously when I made mention of a region, I said a region is basically a physical location somewhere on somebody's land somewhere where AWS has infrastructure. That's a physical location. And in every region, you have multiple AZ. And that's the same thing with a VPC. A VPC span across multiple AZ. And like you say over here, when you create an AWS account, you have a default VPC that is created. And also by default, you can create up to 5 data centers in a particular region. And a VPC, which is also a virtual data center, support both IPv4 and IPv6. Moving forward, a VPC has a structure of subnets, and your subnets are basically similar on-prem where you have a segmentation of your network. It could be VLAN based, or it could be switch based, or it could be a route port based. It's the same principle. And in AWS, every subnet must reside in a particular AZ, which is in a particular data center. And we mentioned before, an AZ is basically a data center. A region is a combination of multiple AZ, usually between 2 and above in a particular regional location connected with fast speed connection. Okay. In a subnet, just like in a network environment, you cannot have an overlapping CIDR block, which is your IP range cannot overlap. If you have a particular IP range for a particular subnet, you cannot have the same thing for another subnet within the same VPC. After the VPC, you have the internet gateway. The internet gateway is similar to your on-prem internet router. That means it's your exit from the AWS environment to the internet. And the same thing you have on-prem. I think when I was showing earlier, something like this, yeah, you have your internet sitting over here, and these are basically your carrier presence, and these are your core layers, usually made up of big routers, and could be referred to as a gateway. And as I can say here, when you take the AWS architecture, for instance, the VPC, you can see the internet gateway sitting somewhere up here. Are you okay? Okay. You have internet gateway that allow you to go to the internet, and every VPC must have one internet gateway. Then you have NAT gateway and NAT instances. NAT gateway basically are another service, or let's say NAT gateway are another service that allow you to have access to the internet, but does not allow you to have inbound traffic. Let me explain. An IGW, which is your internet gateway, is basically your exit to the internet. Okay? But at the same time also is your entry from the internet into your AWS network. That means if you have a server, if you have a laptop sitting somewhere here, and you have some resources deployed over here, let's say a server, and you have allowed port 22, and this particular server is located in a particular subnet that has a route to the gateway, and the port 22 is open, you should be able to get in. And that's what IGW does for you. It's for both-way traffic. But a NAT gateway on the other side is basically a one-way traffic. It's exclusively for traffic going outside, especially for machines that are not supposed to be exposed to the internet. And we're going to talk about another key aspect of subnets in a VPC. In a VPC, traditionally, like you have it on-prem also, I think those who are on-prem will tell me that, okay, you have your LAN infrastructure, and then you have your DMZ, which is another subnet connected to your router that exposes services to the internet. Correct? If it's correct, give me a thumb up so that I know that you are listening to me. Great. Now, when you take your DMZ, in AWS on a VPC implementation, your DMZ should be referred to, or is referred to, as a public subnet. Basically, it's a subnet that has a route directly to the internet gateway. That means any services that you put over here, in that particular subnet, let's say in this example, where you have a public subnet and your private subnet, any resource that you put over here, and that has a route to this internet gateway, will be exposed to the internet as long as you have something we call security group. We'll look at it later on, open. On the other hand, we have the private subnet, which, if I take your data center, is your LAN. Nothing on your LAN get exposed to the internet. And the same thing, it's applied to a private subnet. Anything that you put in a private subnet is not exposed to the internet. But the catch is that sometimes some of those servers need to pull updates. In order to allow those servers to pull updates from the internet, you deploy a small service we call NAT gateway in your public subnets and allow the route from here to go to that particular NAT gateway, so that those instances or servers that you have in a private subnet can have access to the public internet. But inbound traffic, the other way around, is not possible, no matter what. Because remember, any instance in a subnet that doesn't have a public IP address is a private instance. I hope we are on the same page. And for the NAT gateway, there are two types. We have the NAT gateway itself, and then you have the NAT instance. What's the difference? Yeah, one is managed by AWS. We call it AWS Managed Service, NAT gateway. And then you have the NAT instance, which is you spin up your own small server somewhere here, install some Ubuntu on it, enable some proxy, and then force the traffic from here to go through that. That means it's your own do-yourself, DUI, if I can call it that way, NAT gateway. The only catch with that is that it's not scalable, okay? And if you want to scale it up for more traffic, you have to change the size. But most often, I would say, if you want to deploy any resource on AWS in a private subnet that needs internet access, always deploy a NAT gateway. And from my experience, NAT instances are painful to manage. Okay, and sometimes they can fail, and then your servers are not having access to internet to pull update and so forth. And at the end, by the time you realize, it's too late. Okay, then you have routing table. Same thing in your physical network, the data center. You go to your routers, and you build all kind of table to allow traffic to flow. It's the same thing that a routing table does in a VPC. Then we have another component called NACL, Network Access Control. These are basically network stateless firewall. And I think my firewall people are here, right? They should clap if they are here. Those who love staying behind firewall. Yes. AWS allow you to have a stateless firewall whereby you define inbound and outbound traffic on that particular firewall for traffic to flow in and out. And those are subnet level firewall. AWS has also another concept we call security group. These are basically firewall, a second set of firewall, but they are explicit to instances. Like for instance, we have this VPC over here. We have this subnet over here, if I can refer to this one. And then at the edge of the subnet, you have a NACL. We'll see it on the console later on. Then you have this particular server itself over here, which also will have its own firewall. We call it security group, which is applied to the network interface or the server itself as whole. Is that clear? Remember, NACL are stateless firewall, which means that you have to statically define the firewall rule in and out, the same way you do it on your firewall on-prem. Then you have security group, and the principle of security group firewall usually don't exist in the on-prem concepts, I believe, because it's different from operating system level firewall, but it's just another layer of firewall that AWS allow you to configure for your instances. Okay, anything with network card can have a security group associated with it to define the traffic that is coming in. And security groups are mostly for, I would say mostly, but uniquely for inbound traffic regulation. Is that clear? Okay, should I move on? Super. The next component we're looking at, the first one was the VPC core component. Second one are connectivity. VPC connectivity, basically I'm referring to, any question? No, okay. VPC connectivity, I'm literally referring to various methods of connecting to your AWS data center. This time we're not talking about the account. The account is a management structure. Then you have the data center itself. How do you make sure that your AWS data center in the cloud somewhere there can be accessed by your business or your team members? AWS offers various methods. You have AWS Managed VPN. These are basically VPN services that allow you to configure a VPN, let's say a VPN concentrator, or implement IPsec or OpenVPN based type of VPN to be able to connect to that cloud. Okay. You have AWS Direct Connect. The Direct Connect is basically a private link that allows you to extend your data center. For instance, something like this. This is a typical example of a private data center over here, which is physical, that is connecting to AWS using a direct connect. That means it's basically a dedicated, I don't know if I'll call it a layer 2 line, but a dedicated pipe that connects your on-prem connection, your on-prem network to AWS. And most often we are, let's say, give a typical example. We are in Ghana right now. Obviously, AWS is not physically present in Ghana, but in some country, AWS could partner with a major service provider like MTN to be able to allow them to have a direct connect gateway on their side to allow people in Ghana to have direct private internet, like not internet, but a direct private link with their data center infrastructure. That's summary what I mean by direct connect. Then you have transit gateway. Transit gateways are more like, let's say, a hub system that allow you to connect to multiple AWS VPC, multiple AWS data center and multiple physical data center together. That means you are basically linking them in a star topology. That's what it is. Then you have VPC peering. Down the line, you will get to realize that when you are creating a data center, especially in the cloud, you have the flexibility of creating as many virtual data center as you want. And that is even recommended, that you don't keep all your resources in one particular VPC. The similar way, probably you have your physical infrastructure, and then you have a combination of having to have your servers spread across multiple VLAN on-prem or multiple physical location where you have your primary data center and your secondary data center for your failover purpose. You can do the same thing with a cloud provider or AWS in this instance. And VPC peering allow you to connect your primary and a secondary site residing in two different physical locations together. That's the premise of it. And then we have the private link. Private link concept will be a bit complicated to explain to you guys, but I'll try my best. Basically, what happened that the way things work in the cloud is you have some AWS managed services, and I'll give a typical example of it, like something like an S3, which is a storage system or a storage service from AWS. You have DynamoDB, you have Redis database. All those things are kind of managed services. But for your VPC to interact with anything AWS managed service, all the traffic goes through the internet. Yes, of course. People will scream, why all the traffic going through internet? By design, any interaction between a VPC and AWS managed services goes through the internet. But it doesn't mean that it's not secure, because those are all encrypted traffic. But on top of it, for environments that are want to be more secure, they can even go further by deploying what we call endpoints, for instance, S3 has an endpoint that allow you to be able to have a direct connection over a private link between your AWS data center, your VPC, and AWS managed service. That's basically the concept of endpoint or private link. That's what I'm saying. It's a bit complicated to explain it, but I just want to put it out there. Okay, now for migrating your network to the cloud, the strategy usually it's not different from how you do that if you have to probably provision a new site for your network, or even on-prem if you want to deploy a new VLAN. You have to do some homework, right? And the first thing consists in having to understand your own topology. What are you going to do with that new network? And in this particular instance, we are moving workload from on-prem to AWS, meaning that we are going to deploy AWS as another data center of ours that we integrate with our own on-prem network. And if that is the requirement of the work that is at play, you should be able to do some few homework, which consists into understanding the topology, the traffic flow, the security requirement, just like the way you do it on a prem. You need to have your diagram whereby you look at it and make sure that the same way you have on-prem, you have your subnets, design and allocation, IP scheme, you do the same thing for AWS also, or your AWS data center. The third one is connectivity. You also have to evaluate how do you want to connect to your AWS or your VPC, if I can call it that way, your cloud data center. How do you want to connect to it? And what are the various ways available? Obviously, the cheapest one is to have a VPN or an IPsec VPN that everybody's knowledge about. We all know how to do that. The same principle apply over there. And then you need to have a migration strategy. How do you migrate your services? What are you going to migrate first? How do you test all those things? The same way you do it on-prem, that's basically the same logic that you are going to use if you are deploying your data centers on AWS and having to integrate it with your environment. Any question? At least one question, please. Okay. I'll proceed. Now, we're now going to explore the network aspect of AWS. Okay. This will bring us back to the console. Okay. All right. Cool. Yeah, we are coming back here. Like I said, the services are here. Let me see which account is this. Are we in the right account? Nope, this is a different account. We'll look at that one later on. But I think this is the one I'm looking for. Yes. Okay. Like I said, all your services are listed here. And for us to have access to a VPC, we're going to go here and just write VPC. And VPC console is going to show up. Like I said, AWS or the VPC is a construct that spans across multiple AZ, but that reside within a region, which is a physical location. And for the purpose of this exercise, this is where you see where all the AZs are located. And you can see if you want to deploy AWS VPC in the US, these are the various physical location that you have. And I believe if we do a small Google search, let's see. If we do AWS regions, let's see. 1 second, guys. Okay, sure. All right, I think this first session is getting longer, but yeah, quick overview. Yes, as I was explaining earlier, if you're in the US, this is where these are the various locations you can actually deploy your AWS resources. In North America, these are the various places. In South America, these are the various regions. Anything you see in blue is basically an existing region. Sao Paulo is here, and the red one are incoming. And literally, AWS has region span across the world with multiple data centers. Okay, now let's come back to our console. Like I say, for this, we are going to create our first VPC using the AWS console. All right. First, we click on create a VPC. You have these two options, VPC only or VPC with more. With more simply means that is allowing you to input more information on the structure of your VPC. Otherwise, you can use this simple one. But for us to have the visual view of it, we're going to use the AWS with more. We're going to give it the project name. Maybe this one is AWS training VPC. That means this will become the name of your VPC. As you can see, as you are creating, you can see the structure right away. By default, it's creating multiple subnets for you. You have two subnets in, how do you call it, in the first AZ, because this represents your availability zone, and another availability zone over here. And it's creating basically two, one private and one public, one private and one public. Okay. And here, I mean, we can keep the IP address to this range. And usually on a VPC, your default CIDR block is /16 for the CIDR block itself for the VPC, and then all the subnet can be whatever you want. Okay. And for here, we're gonna maintain the default, which is 10. And then here we're gonna go how many subnets, number of availability zone. That means say 2, and you can see availability zone is basically a data center in a region, in a particular location, and multiple availability zones are connected to each other through a high-speed connection. And if I want to make it 3. If I click on 3, for instance, automatically you say is adding a third region, a third AZ to this subnet, while still making sure that I have a private and a public. And at the same time, while creating that, you can see that every subnet has its own routing table. For instance, this is a routing table that connects all your private subnet or all your public subnets together to allow traffic to flow. And you can have the visual view of that. And then we set a number of subnets. We are creating 3 public subnets, 3 private subnets. And then in this particular session, we are not creating any NAT gateway. We are not creating any VPC, or how do you call it, VPC endpoint. We are not creating any of that. We just click on create, and we just wait for AWS to do the magic. Imagine on-prem, you need to deploy a data center. Just imagine the trouble you have to go through. But in case of going to the cloud, it's just a couple of clicks away, and that's it. Here we are. Our VPC is created, and we can see we have a VPC ID. We have a main routing table. There we can look at the structure over here. You can see all the various subnets that we have all the various subnets over here. We have the routing table that allows traffic to flow. And at the same time, also is also creating an internet gateway for us. Like I stated previously, you need an internet gateway associated with every VPC. And we have all these things created at once because we've used I think the other option, which is not the VPC only. Now we can just click here and see our subnets. Let me just come over here and choose our VPC, which is training. When you go over there, I think we can see all the 3 subnets that we created. So let me see. I think, are we on the right one? Let me just refresh this page and see if it's doing what I expect. Okay, here we are. Let me see. There's something strange though. Let me refresh this page and see. Now we have more than I expected. Here we go. Yes. Now we have all our subnets, and we can see the side block of that subnet. I mean, it's literally in this particular implementation, we are looking at 6 subnets, 2 subnets in each region. Then we have routing table, and you can see the routing table carrying their name also. We have routing table for private subnets, and then you have routing table for public subnet, and you can see this subnet has 3, this routing table has 3 subnets associated with it. We're going to look at the detail later on, but maybe you can just click on it and see here. Okay, good. This is a typical example when I was talking about public and a private subnet. A private subnet simply means that there's no gateway to the internet, but a public subnet means that you have a direct route to the internet. And here is a typical example where we have training routing table called public, which has a default route to the IDW. Now let's look at the private one. As you can see, the private internet, the private subnet, for instance, in this particular situation, which are 3, they don't have any route to the public internet. That means there's nothing you can place in this particular subnet that will be accessible from the internet or have access to the internet. Any question? No.
Yeah, I did notice one thing too, that the public ones, they had 000.
Yes.
Yeah.
Yeah. In a typical AWS fashion perspective, the default gateway, similar to those who are on the LAN, on on-prem. When you're defining your default gateway on on-prem in any of your router, for instance, you always use the destination 00000, which means the internet, right?
Yes.
Yeah. The same principle applies here. That means this destination, which is internet, must go through this particular gateway to reach the internet. That means you basically, while creating this thing, this particular VPC, we created a routing table. And because we say that this subnet is a public subnet, automatically it's associating the destination 0.0.0/0 to the routing table and send the target being your IDW. Is that clear?
Yeah, that's good.
Okay, cool. Then you have your IDW. Obviously, like I said, every VPC needs an IDW because that's your exit and your entry, your exit to the internet and your entry into your virtual private cloud from the internet. Even though there are other ways of getting into your VPC using either a VPN, a direct connect, transit gateway, and all the rest. Okay. I think I will skip the other one. Here we have a DHCP option, which I was also skip right now. It's not part of the scope of the conversation. There we have NAT gateway. As you can see, there's nothing here in the network session because we did not define a NAT gateway during that creation, but we can actually do it manually if we want. Okay, but for the purpose of this training, I don't think we can do it right now because time is also against us. Then we have the peering connection, which also is also blank right now because we just create one VPC. Now, we create one VPC here. We can create another one by simply going back to VPC, and this time we create another one, but this time we're going to do it manual, okay? So that you can be accustomed to it. And this one, I'm going to call it AWS Training VPC 2, okay? I'm going to use a cider block of of 10.100.0.0/16. Okay. And like I said, we also have the option of having IPv6. And here we're going to keep it no for now. Forget about the tenancy. And then I'm going to add in a name. And this name was basically what was given. I mean, it's actually the tagging. And I think we already have the tagging over here. Okay. We click on create. Let's see if it's going to create it or not. Okay. That got created. But this is the catch. This new VPC that we created is basically, let me refresh this page to make sure that it's showing. Okay, this is the second VPC that we created. And the funny part is that if we go into the subnet session, there's nothing. Who can explain why we have nothing here? Anybody from what we've discussed before? Who can explain? Yeah, okay, so Sue, go ahead.
What comes to mind is we've not linked any subnets to it. So
Okay.
there is no way to, whether private or public.
Super. Awesome. Exactly that. You see, that's what I'm saying. Like this, when you, sometimes the lazy way hide a lot of things from you. And if you look at the first way we created it, we created using the option where additional resources are defined automatically for us. But then when we choose the VPC only, we are basically saying, okay, we are creating an empty VPC. That means just give us just carve an allocation of part of the AWS data center for us. Nothing added yet. Now we're now going to come and say, okay, we refresh this page. This browser is fooling around, but either way, we come back over here. Now, what we can do is that, okay, we go ahead, Coffee.
No, I think I saw two people's hands were raised.
Okay.
So Sue and somebody else.
Okay, I think I missed that one. Yep, the other person can jump in. Any other question? I think. Okay, there's no question for now. I'll proceed. But in the meantime, right after this, I just have a question. Do you guys want us to take a break and continue later? Or I want to see how tired are you or how bored are you guys? So yeah, go ahead.
Yeah, as for maybe I'll say maybe we do the manual creation of the subnet and then we can continue the session.
Okay. When you say continue the session, now or later?
Later. So maybe
Okay.
a part 2.
A part 2. Okay, all right. That's awesome. But I hope you guys are having fun. For those who are that have a little bit of idea of what's going on. Okay, cool.
There was also Jesse. Jesse also raised his hands.
Jesse, yeah, you listen.
Yeah. As far as I'm concerned, I believe we can proceed with it. And then, as also said, by virtue of time constraints and looking at the number of people on the call, probably you can result in a second session.
Second session. Okay.
But
awesome.
if we have to proceed, I don't mind actually.
Yeah, I think what we can do is that we can actually stop after we can wrap up around the VPC because it's one of those critical resources like services that we all need to have a good understanding of, and we can have a second part where we're going to tackle other resources. It can be second, third, as long as you guys show interest, we'll be able to proceed. Okay. Awesome. Okay, now we move to the the subnet part. We just created a VPC, which is like we just draw some lines, say, okay, we want this place as our data center, and this is the CIDR block that we want to have within that particular data center. There was no subnet, there's nothing. Now we're going to proceed and create our own private subnet. Now, when you're creating a subnet, you're going to choose your VPC. Here, remember by default, we have 3 VPC in our account now. The default VPC that was created when the AWS account was created, it always comes with every AWS account. You have in every region, you're going to have one VPC that is the default one, but we never use it. We all stay away from that. We don't usually, we also don't delete it, but we just don't use it for any production because it comes by default. Now here I'm going to choose my yes, because I think I have a recollection one day whereby I think I created an environment and I deleted the default VPC, and it turns out that some default AWS services relies on that particular VPC to operate effectively. Therefore, since that day, the rule of thumb is create your additional VPC without touching the default one. Cool. Now we're going to create a subnet. We give it a subnet. We're going to give it a name. Yeah, we're going to give it our own custom name. Let's say I'm going to call it, because it's going to be a private, I'm going to call it private AZ01. Okay. And I'm going to choose the availability zone. Like I said, every subnet is submitted to is associated with an availability zone. And availability zone is basically a data center in a particular geographical location. Okay. And you can have multiple data center or multiple AZ within a particular region. And here, because we are using 01, I'm going to put it in the first one. And oh, I forgot to remind you. Remember, as I'm creating the resource, it's taking in consideration which region I am in. Right now, I'm in Stockholm. That's the region in which I am. But usually, I have the tendency of preferring creating my resources within a different region. But we're going to keep it here for now because this was the default one that we have. But you can choose any other region. For instance, if you're deploying resources for a data center in UK, obviously you want to be able to deploy your VPC in the London region. That means always make sure that your VPC is closer to where your service is going to be consumed. But here in Africa, I think among all the region, UK or London side is closer to us. That means in real life implementation, if you're going to provision or you're going to create a data center for your organization or a VPC for your organization, always look around Europe, Europe, and you can choose any of the region over there. Okay, cool. And then I'm now gonna choose the startup block for the VPC is automatically picked, but now for the subnets, we'll have to now choose one. Let me again put it 10.100.1.0 and then /24. And then I'm gonna keep the tag. You see the tag by default is gonna pick it private AZ1. I'm gonna create a subnet. Now we have our first subnet that is created. The next step is to create one public subnet. Okay, I'll choose the same AZ, and this one is pub AZ01. I'm going to choose the same region. It could be a different region, but for the purpose of the training, I'm going to choose a different region. And this time, my starter block is going to be 10.100. Let's say 100.0/24. And we keep it like this, and we click.
Please, I have a question.
Create. Yeah, go ahead.
Wait, why didn't you use like 2? Why 100?
No, I mean it's just a preference for me. Usually, what I do is that when I'm choosing the digits, for instance, I'm creating my private VPC, my private subnet, for instance. If I choose 1 for the first private one, you will see that all the other private one will fall within that same digits. That will be 1, 2, 3, 4. It's just a preference. And then when I'm choosing 1 for the public and I choose 100, any other public I'm going to create that will be in a different region is going to be 100, 101, 102, just for mental mapping. I mean, there's no choice. As long as the subnet you choose or the CIDR block you choose is within the VPC block itself, you are good to go. You just have to look at things from your own perspective, like which one is easier for you, so that when you look at it right away, you'll be able to tell, oh, this is my public subnet, this is my private subnet. Okay, there's no rule of thumb for it. It's just preference.
Okay.
Okay. All right. Okay. Cool. Now we just created a second one, a public one. But remember, we are in this AZ. We are in this particular region. Let's say the same VPC, which is 2. Now we have subnets. Oh, and guess what? Routing table. Let's see. What do we have in this routing table? There was a default routing table that is created. And usually there's always, it's called main routing table. For every VPC, there's a routing table that is created, allowing traffic from all the subnets to reach each other. Does that make sense? For instance, you have a how do you call it? You have a subnet in AZ1 and you have another subnet in AZ2, or you have 4 subnets. By default, AWS makes sure that traffic can flow across all the subnets without any restriction. And this is done using this main routing table. Okay? Now, as you can see, we have 2 subnets. We have 1 routing table. Another rule of thumb is that it's always better to create your own routing table than trying to play around with the main table. For that reason, we're going to create a routing table. And this one, we're going to call it hub RT01. Simply means this is going to be a public routing table. This is going to be a routing table for public subnets. Okay? Now we're going to choose the VPC. We keep the name like this. We create. Now, when you go to routing table, we have this new routing table. Because we say this is a public routing table, that will mean that we have to define a route entry that allows traffic to go to the public internet. Correct? Let's go to this one. Go to routing table. And you can see we create a new routing table, and you still have that first one entry over there. We're going to edit this, and we're going to add a new route. And the new route is going to say destination everywhere on the to the internet. Give me internet gateway, and select the internet gateway. I think this one. Let me see if there's a one. Oh, good one. We create a VPC. We started creating a subnet, and we forgot to create an internet gateway for this VPC. Knowing that every VPC must have an internet gateway in order to be able to route traffic to the internet. We omitted that step. Therefore, what we're going to do, we're going to add one. Okay? And we're going to call it VPC 2-IGW. Remember, naming scheme are really important for your visualization purpose, because sometimes it can get overwhelming when you have random names that you can relate them together. Okay, because we created VPC 2, I'm just naming it this way also. And we just created the IGW, which means that now we just with a click of mouse, we just bought a router from the market and add it to our network. Imagine you have to do that on-prem. Procurement, good luck. Okay, then we're coming back to the routing table. We create a public routing table before. Now we're going to do the routing entry. We're going to edit this one. And then we say adding destination is everywhere or anywhere on the internet. Internet gateway. Let me see why it's not refreshed. It's not appearing. Let's see if we have added to the right place or not. I think probably this one is the one caching. Let's see. IGW. Interesting. Let's see. Yeah. Any question? So go ahead. Yes. As we created a routing table, good news.
I think
another step.
I think the internet gateway, we've typed a prefix.
Yeah, we need to attach it to the VPC. Another catch.
Okay.
We come over here.
But I'm saying the one we are searching for.
Yeah, because we created it, but we didn't attach it to the how do you call it? The VPC. Okay. Let me see if we have this one. Let me see if it's that you see right now here, we have it created, but there's no attachment. Okay. Let's see if we can click on it and go to action and attach it and choose the VPC that is supposed to be attached to. Now, here we go. Now, this particular VPC is attached to, this particular IGW is attached to a VPC. That means exactly like we see over here. You have your VPC, and then you have your IGW. You created it manually. Now you have to attach to it. That's how cumbersome a manual process can be. And if you don't remember each of the steps, then you find yourself in trouble. Okay. Now that we have attached it to the VPC, I'm pretty sure if we come to this routing table, yes, that's what another better option is, to use automated tool like Terraform for infrastructure as code. Then you can just codify those things and makes life easy. Now we're gonna go edit. We're gonna add. Come choose a route. Come here, IGW. Come on here. Here is showing up, and then we click save. That means now this route, this particular subnet, or this particular route table has a route to the internet. Let's see if there's any subnet associated with it. Oh, let's see. Right now, we can see that there's no explicit subnet associated with it. That's another manual process. You create a VPC, you create an IGW, you add the IGW to the VPC. Same way you do on-prem. Now you create a subnet. You add a now you create a subnet. Now what do? You need to associate the subnet to the routing table that you created. That's the thing. Now we're gonna go here and edit the routing table and select our subnet. We are choosing the public subnet because this routing table is meant for public, for how do you call it, public traffic. And then we click on save. Now when you come to subnet, you can see that your public subnet is now associated with it. Does that make sense? Now we just did the manual process, like the automated process manually, and look at how many hoops we have to go through in order to get it right. But if you compare that with having to do that on-prem, you can just imagine the hassle. That's, I think, this brings us to the end of this first session. I think we've gone through a lot because, like I said, that's why I said from the beginning that this is supposed to be a long boot camp, not a short session. And today we only touch on two things, which is creating an AWS account, configure the IAM, create an IAM user, and then create a VPC, and a VPC, which is a data center in the cloud. Unfortunately, today we'll not be able to create a resource to be able to test that, but I'm pretty sure we're likely going to have a second session where we'll go through the second step of now creating resources into that and do all the various tests that we have to do. Whew, that's a lot of talking. I hope you guys have fun.
Oh yeah, I'm having a lot of fun. I'm even looking at.
I'm gonna pick one person. Go ahead.
Yeah. After the second session, I'm even looking at a follow-up session or how to do the same thing via Terraform.
Oh yeah, welcome to my club. I don't do this thing. I mean, I barely come to AWS console. I don't remember the last time. That's why usually anytime I come here, I get confused. I usually build everything with Terraform. I don't do manual thing, but yes, you need to start from the physical aspect, like the console click by click, before you can even go to Terraform. And I think it's gonna be a nice session to look at. Maybe if I'm sending some information out, I'll even send a public module or a custom module that you can even use if you want to play around with the Terraform session. Okay. Cool. Can I ask somebody to summarize what we've gone through during this, how many hours? An hour and a half, I guess, if not more. Who wants to volunteer himself to summarize what we've done today? Okay, Jesse, the mic is yours.
Okay, I'm going to make it very brief. So basically, our main goal for today was to dive into the whole concept of migration from on-premise to the cloud, because we know that several companies still use the traditional approach where they are not using the cloud. So we needed to learn how to migrate this entire infrastructure to the cloud. So we started by diving into AWS, learning the various basics that we needed to understand. and then we dive into creating a virtual private cloud, which was should I say, a very extensive session where you need to understand subnet, internet gateway, among others. We and all those informations were more of networking, and then yeah, I believe this was a major aspect that I took from.
Awesome. Thanks. Anybody else have anything to add?
One thing that I could also add was that this session was quite insightful. I really like the approach of the manual way to see how you can create things and how the theory ties into the practical as well. I've always had a bit of trouble trying to understand this stuff, and yeah, this session really breaks it down. So yeah, looking forward to subsequent sessions.
Awesome. And that's actually the intention, because me personally, coming from somebody who has been rack and stacking networking components, then having to move to building SAN infrastructure, which is storage network, moving to virtualization, the main objective of this session is to be able to take you guys through that route, especially somebody who is on-prem. Even for developers that's usually always running away from networking, so you are one of them, bringing you closer to the pain that we go through, and having to go through the manual process of tying all those things together was the main objective. And I'm very happy that you guys all took time from your busy schedule to attend this session. And I'm pretty sure that we're going to have a second part very soon. Okay. Thank you so much.
We are not done. Hey,
okay.
You don't have to rush off. We have two people with their hands raised.
Awesome. All right,
Jesse
Edward.
and Edward. Yeah.
Okay, Edward, the mic is yours.
Okay. Good evening. Thank you. So during the session, we considered AWS as a case study as one of the cloud services. And one thing that I understood was that never use root account for your AWS operations. Whenever you create your root account, make sure you have other users that you assign policies and other stuff to that you can use to manage your AWS resources or services. Thank you.
Yeah, thank you for pointing that out, because that is very imperative. Because I remember back at AWS, we have a session where somebody called and report that he has 300 resources with images and everything that was wiped from their accounts. And it turns out that it was just somebody who was pissed off that has access to the root account, and the other person just zapped the entire infrastructure of a company like that. And it's a common thing. That's why it's always required that anytime you get to the cloud, make sure that you have your MFA, either a root account or any user account. Make sure that everybody has an MFA. And in a traditional sense, also another thing we do is that we have credential rotation. You have to make sure that according to standard policy, every 30 days or every 90 days, every AWS account has their credential and probably access key expire so that people can reset their credential. That's another major step that you have to take when you are dealing with the cloud. Not only AWS, but any cloud service. Okay. There was a second person that has his hand up.
Yeah. Thank you very much. Today I've really learned a lot. I think before you start creating your VPC, the first thing you have to do is to create your architecture. Like you draw the architecture, then you can based on that to create your VPC and add your subnets and your other stuff. Yeah. So yeah, I've really learned a lot. Thank you very much.
Yeah, you're welcome. Yeah, exactly that. The same principle on-prem, like the way you do things by planning, you do the same thing with any cloud provider. Never forget that, because one of the things that we overlook is that, oh yeah, it's easy, we can just do a couple of clicks there. We forget about the planning aspect of it. Then we create, then we delete, we create and delete, forgetting that every create and every delete has a cost implication. As you create a resource, and it's being provisioned, like in this particular instance where we provision an IGW and all, typically like an IGW, for instance, it has a cost that comes with it. It has a cost for the provisioning for the existence of that particular router, and then it has a cost for the data that goes through it. Therefore, in the cloud, if you don't plan properly, you end up with overcapacity, or you deploy resource everywhere and you don't even know where they are, especially when it's manual. Like right now, as we finish this course, I have to go and wipe everything if I don't want to have bills start coming. Okay. Yes, back to you, Kafui.
Yeah, I thought
Okay.
Jesse, but Jesse didn't speak. So Harrison, and if anybody else is there, if not, we'll just wrap up and then we'll reach out to you later on the next available date for the session. But it should be sooner than later. Yeah, so Harrison.
All right, thank you very much, Kafui, and thank you very much to Christopher. So mine is more of a question. So I think throughout the session, most of the things have to do with networking. So I'm asking, as a beginner, how much networking should you know before you can delve into the cloud?
Yeah, that's a very good question. And I believe that as a beginner, you still need to know networking. Maybe you may not know it from having to have hands-on experience in the implementation on-prem, but it's a prerequisite for you to go to the theoretical aspect of networking. It's fundamental because the principles are the same. Okay, the principles are the same. Therefore, for you to be able to build a solid network architecture on AWS, it would be good to even take a CCNA course, which allow you to have the foundation for networking on-prem. People tend to jump that hoops, but at the end of the day, it all comes back to the same thing, especially when you have to sometimes manage environments that are not just all cloud, but you have a hybrid implementation where you have to integrate your on-prem infrastructure with the cloud. That's networking at a high level, at the low level. That means serious deep dive. Therefore, I would say for you to become conversant in the cloud, it would be good to have at least a decent network background. Developers tend to take that for a ride, but in my humble opinion, it's necessary for you to have that foundation. Cool. I think there was one last person.
Okay, I guess.
Any other?
Is Victor still around? Victor is our community manager, by the way. Okay.
Yes, please, Amanda.
All right, Victor. Over to you. Yeah, let me answer the question of Titus raised. So Titus, because this session hasn't ended, we will not share the slides yet, but I bet you can do some online research just to fill up some gaps if you have any. Once we are done with the second session, we'll share the slides. This video will be online, so everyone can have a way to refer to them in the future. And there will be a bonus project at the end of it, or for everyone to try their hands on. And then he will also be available. Christopher will be available for any further engagement. Of course, for free, because he's availing himself as a volunteer for the Crado community. Okay.
Okay. Thank you. First of all, thank you, Christopher, for spending wonderful time. It's almost 2 hours, and I was afraid after 1 hour when I was thinking people will leave the meeting, but I think we are having still a good number of people, and a lot of people were still joining. So we want to thank everybody. First of all, sorry for the interruption which we had earlier with, I think Google Meet was done, but we are happy that it later came back. So like Christopher said, we are going to schedule the next section. So everybody, check your email. If you've not joined the community, you can join our WhatsApp community. The link, you can join our WhatsApp community. Whatever information you want, we'll paste there. And also, the next session, we are going to send email to all those who have registered. So thank you and good night.
Thank you all. Have a lovely rest of the week. Cheers.